All right, everybody. Welcome to my presentation. We have a little quiz for you. And this isn't really a quiz, it's more or less like a live call and response. So if I say competition technologies, what words pop into your heads like immediately? Not Terraform. Ansible, nice. What else we got? CloudInit, cool. OpenStack, yeah. No. That's not really a technology, but okay, we'll take it. What else? What else we got? Yeah. Technologies. Yeah. Terraform. All right. So this is going to be a presentation about the code that supports competitions that we do here in this club. So we have the four horsemen of the competitions. I was going to make a nice meme, and then I ran out of time and didn't do it. But the important things, the four important horsemen of the competitions are images, Terraform, Ansible, and Git. We use all of these things to build and deploy like things like IRSec and things like ISTS. We don't use them to do the CTF because that's not my responsibility. So talking about some of this stuff here, we have images. I'm sure everybody's familiar with many types of image files. You have OVAs and OVFs, you have VMDK images, you can have VirtualBox images. You also have ISO images that you can use to install any kind of operating system onto a virtual machine or actual hardware. But the fun thing about ISOs is that while they're ubiquitous, the stack cannot take an ISO file and like make it into an actual virtual machine, which is kind of annoying. So we can use a fun little utility called QEMU to convert the image of a type ISO to a QCOW image or a RAW image, and we can use this RAW image, upload that to the stack, and use that image instead, which is pretty powerful. In the off chance that we can't find an ISO file for an operating system, we can build that operating system basically from scratch using Packer, which is something that we haven't done in a little while because we had images that worked pretty well. So we haven't, Packer's not something that we've used recently, but it's something that you can use if you need to build a custom image. It's built by HashiCorp, which is the same company that builds what other tool? Vagrant and Terraform and a bunch of other stuff. Pretty cool company. They use a combination of HCL and JSON to build these images, and it's interesting stuff over at Packer. So the first step in building a competition is getting your golden image, and this golden image will take everything that you need. Well, it'll take like the base requirements you have for whatever virtual machine you want to use. So say you want to use an Ubuntu virtual machine to host. Anthony, give me a service. Okay, another service. Like something they have to install. Okay, not WinRM or curl. But I like curl because we'll just use like we'll extrapolate to web. We'll extrapolate to web here. So say I want to run a web server on an Ubuntu box. My base image here is going to be an Ubuntu server, probably without a desktop installed because that's kind of not necessary. And then later I'll use Ansible to install like Apache and MySQL to host this web server. So that's how images more or less work. What we like to do is build one image per operating system and then use that to build out and deploy our services from there. We have images for basically every major distribution of computer architectures out there now, except for like Windows 11. Any questions about images? Cool. So when you spawn a new instance on the stack, which is equivalent to saying when you create a new virtual machine, if you don't do anything to it, it's not going to work the way you want it to at first, because it needs a little thing called CloudInit or CloudBase in it to configure the instance on launch. So Cloud Init is a wonderful tool that allows us to do basically anything you can do like in Bash or with like PowerShell. You can do it with Cloud Init or Cloud-based Init, and you can use this to create a user or create a password. You can use those update packages and do some like prep work so that you can then configure things using Ansible later on. So with Cloud Init, it's a YAML formatted tool. So if you use YAML to write Ansible, then you can use YAML to write Cloud Init, and it's pretty awesome. Also on Windows, instead of using actual YAML syntax, we use PowerShell, and we use this to prepare Windows for Ansible. There's a couple of configurations you have to make, like opening up WinRM and opening up other services, and just allowing like WinRM scripting so that you can actually like use Ansible later on. So there's support for this across all major distros. I looked yesterday, and there's not support for it for pfSense, which is sad, but c'est la vie. So, any questions on this technology to support that we use to support our images? All right, Chris, what is one language that you can use in Cloud Init? What is one language that you can use in Cloud Init? Guess what? It's YAML. One of them. Cool. Moving on. So, Terraform. I've given many talks about Terraform and how it's really awesome and cool. So I'm not going to go too much into how it works, but I will talk about how we use it in like from a higher overview. So Terraform is an infrastructure as code language. It allows us to build out instances, build out networks, build out routers. There's anything that you can do physically, you can do in Terraform. And that's how we do massive deploys of like 225 VMs for competition with relative ease and not doing each of those instances by hand. So there's 3 parts to our Terraform setup that we use for our competitions. The first one is the project's Terraform. Second one is the management Terraform. The third one is the team's Terraform. Does everyone want to take a guess on what each one of these parts does? Anthony's thinking. Yeah. What does each of these parts do? Okay. Okay, Brayden, let's hear it. Sounds good. Yes. Yeah. Fair. This is good. Anthony, want to? Sort of, kind of, but yeah. All right. So the project Terraform, it creates one project in OpenStack, like called like the ISTS project or the IRSec project, and then we create quotas. And what quotas are is basically a limit of how much of each resource we can use. So we have a networking quota, which defines how many static IPs we can have, how many floating IPs we can have, how many routers, how many networks, how many subnets, all of this fun stuff. I generally set reasonable quotas for each of those, except for the floating IPs. That I take all the floating IPs for. So then, also in the project, we can assign like block storage quotas. So like how much cores are, actually that's the compute quota. Block storage is like how many volumes are we going to have, how big can each volume be, and how many snapshots can we take, and other stuff like that. The compute quota relates to how many cores I can have, how much RAM I can use, and how big each disk can be as well. So we set these quotas so that we can limit, not like you want to pick good quotas so you can limit your project to a reasonable size. But for competitions, we just take everything we need, including all of the floating IPs. Then we add a stack user groups to the project. So there's a competition architect group on the stack. We also have a black team group on the stack. We add those as admins into the competition project. And then we create our security groups, which is a synonym for our firewall rules. We create those in here so that we can then apply them in our for instances that we create later. Any questions about Project Terraform? None. Great. Okay. Management Terraform. So here we deploy our networks. These are all the networks that we deploy. We have stuff like the team LANs, the team clouds. We have a management network that all of our management servers sit in. We also have a VPN network and a red team network. Those are kind of the same. There's a list of all the services that we deploy in the management project. We have our DNS servers. We have a Chocolatey server. We have our deploy host, VPN. We have our scoring servers. We have a logging server, a game. We have an uptime monitor for management services, and all this cool stuff. So then moving on to the team's Terraform. This, as Braden was saying, deploys all the infrastructure that the blue teamers use to access the infrastructure and compete with. So in the LAN, we generally deploy a router, generally deploy a DC, some client jump boxes like a Windows 10 client, some Ubuntu machines that they can use to access their cloud services, and just like other scored services that whatever the CA wants to be in the LAN goes in the LAN. Then we deploy stuff in the cloud as well. We generally have web apps and databases and other file servers up there. The cloud and the LAN, they both kind of fill whatever purpose the CA has come up with and kind of envisioned for this competition. Then we also will incorporate any other MISC requirements. So for ISTS, we'll add in a Koth access network here so that blue teamers can use the Koth jump box to get to the King of the Hill network and compete over there. And for IRSec, we'll also add in a third logging network that we do some networking magic with so that blue teamer levels have access to the logging server so that they can do instant response at the end of the competition. Big water guy. Sky, stay hydrated. So moving on to our third horseman of the competition technologies, we have Ansible. And there's also been plenty of talk about Ansible and how to write it and how to use it out there already. So I'm not going to dive into the specifics of how it works, but this is how we use it from a higher overview. So like we have our breakdown for how we use Terraform, we have a similar breakdown for Ansible, where we have for management Ansible, we have Linux and Windows Ansible, we got logging Ansible, and just like other MISC things that need to happen. So as you could have probably guessed, our management Ansible deploys things in the management network for Black Team to use and supports the rest of the competition. So we install DNS, we install a Chocolatey server. Chocolatey server, actually, anybody not know what Chocolatey is? All right, Kenny, you want to toss us a little explanation real quick? Yep. Uh-huh. So, in the past, when trying to install packages for Windows, we would get rate limited by like official Windows servers because we were trying to like install Windows client software like 50 times from the same public IP address, which looks like a bit of a DDoS attack. So we downloaded those packages once, and then we created a Chocolatey repository and upload the packages there, and we just pull everything internally without having to leave the public internet, go to the public internet, which is a pretty smart idea. We also have a deploy jump host that people can use to access the infrastructure. We deploy VPN. We also have our scoring and beat services for scoring. And at the end here, like the infrastructure, going back to the like the team slides that I talked about, that I gave a little presentation on about like December, about how you like run a good Black team. We talked about an infrastructure team. We talked about scoring, logging, and other teams. So infrastructure will handle most of this stuff. but then the scoring team will set up the scoring server and the dynamic beat service. Then a logging team will set up the logging server and configure everything to work in that way. So at some point, we kind of with the infrastructure team kind of hands off the deploy of management services to the respective teams so that they can handle them and get them set up and rolling. So with the team's Ansible, we have our Windows team that will handle setting up everything on Windows. We have a Linux team that will handle setting everything up on Linux. The general format for both of these is just adding users and installing services, a very high-level overview. For Windows, there is some additional stuff that needs to happen, like running Windows standards that sets some things to make the whole deploy a lot easier and just kind of gets everything ready for deployment. And on Linux, we have something similar that just kind of checks whether sudo actually works and just kind of make sure that everything is ready to go. So looking back on our third technology here, we have our Ansible, and we have management Ansible, and we have our Windows and Linux Ansible, and every team generally writes Ansible to install whatever they need to do and contribute to the competition. So here's a high-level overview of what logging does. There's been talks in the past about how logging works for red team and black team, so go check those out if you want to learn more about that, or talk to anybody on the logging team from our past competitions. I'm sure they'd love to tell you all about their things that they learned and all of the wonderful things that they dislike about logging platforms. So our fourth technology competitions is Git. We use a GitLab instance to manage our code bases and manage our development cycles, so that way we can share our code, we can have one centralized source of truth, and keep everything organized. So there's been plenty of talks about Git as well. The aspects of Git that we use are branches, issues, milestones, and we've used worksheets for the past 3 competitions. We're trying to move away from them as it became very confusing. So that using Git allows us to stay organized and keeps everything neat and orderly, and it works out pretty well. So that's our last horseman of the competition technologies. So putting them all together, about 3 months before the competition, you want to have your images finalized, so that way we can start deploying them with Terraform. About 2 months before, you want to be kind of done with the Terraform so that everybody can start testing their Ansible. With about a month to go, the goal is to have the Ansible done, so that way we can do just like a good check and make sure that everything we thought was deployed and was deployed correctly. At this point, you want to have a green board. You want to make sure all your users are there and working in the right way. And then you want to open up the access for red team to do their pre-comp deploy. And then you get to sleep for like the week before the competition. And everybody comes into the day we get hands-on and is super well rested and very happy. So combining this talk with the talk I gave about how to run a black team, this is pretty much how you do competitions and how we do them here at RITSec. So if you're interested in any of the stuff, so if something that was said here or there was like, ooh, that's cool, or I want to do that, then the next time the black team interest form comes around, sign up. It'd be wonderful to have you on the team. If you have any questions, you can reach out to me, talk to Michael Vaughn, or you can read up in the Black Team wiki, located at blackteam.ritsec.club. And if you still have questions, then Google is your best friend, or talking to people. So with that is my presentation.